Dear students, in this lecture I am going to discuss about earned value analysis. In the previous class I have discussed about planning, monitoring, controlling cycle. So, next topic is earned value analysis. So, the agenda for this lecture is I will explain what is earned value analysis, then I will explain various elements in the earned value chart and how to calculate various cost variances, schedule variances and so on. Next we will talk about estimating percent completion. When I am discussing this earned value chart, there I will discuss about various terminologies used and different variances. Then we will discuss about I will take a sample problem, there I will explain how to construct or update the project's earned value analysis. First we will discuss about what is earned value analysis. So far we have covered monitoring for parts of the project. Monitoring performance of the entire project is also critical, because performance is the reason for being of the project. So, measuring the performance of the entire project is more important, inevitable. Individual task performance must be monitored carefully, because the timing and coordination between tasks are essential. Not only measuring the performance of overall project, also we should measure the performance of an individual task, but the overall project performance is the crux of matter and must not be overlooked. One way of measuring overall performance is by using an aggregate performance measure called earned value analysis. That topic only we are going to discuss in this lecture. Next we will discuss about earned value chart and its calculation. A serious difficulty with comparing actual expenditure against budgeted expenditure or baseline expenditure for any given time period is that the comparison failed to take into account the amount of work completed relative to the cost incurred. So, what is happening? Many times we compare the expenditure, what is the planned expenditure and actual expenditure, but many times we fail to recognize, fail to measure the amount of work accomplished. So, in the earned value analysis we will include this important element apart from budgeting requirement, amount of work actually accomplished for measuring the performance of a project. The earned value for work performed or value completed for those tasks in progress is found by multiplying the estimated percentage of physical completion of work for each task by the planned cost of those tasks. So, if you want to write in the equation form what is the earned value, when you multiply percentage of physical completion of the work, then multiply by planned cost. So, that will give you the earned value. That also in the work done, actually we are measuring in terms of cost. So, the previous equation result is the amount that should have been spent on the task so far. This can then be compared with the actual amount spent. Making an overall estimate of the percent completion of a project without careful study of each of its tasks and work units is not sensible, though some people make such estimate even so. So, what is important? The study of the completion of each task completed is also important, then only we can get an accurate estimate of the overall project completion. Indeed, it is apparent that any date during the life of a project, the following general condition exists. Sometime some work unit have been finished and are 100% complete. Some work units have not started yet and are 0% complete, see either 0 or 100. Other units have been started, but are not yet finished, and we may estimate a percent completion for this latter group also. So, here only the concept of percent completion comes, because it is easy to say whether the project is fully completed 100% or the project is not at all started, but there may be a task which are started but not yet finished. There the concept of percent completion of the task comes. So, as we said, estimating the percent completion of each task or work package is not trivial. If the task is to write piece of software, percent completion can be estimated as the number of lines of code written divided by the total number of lines to be written, given that the latter has been estimated. So, this is the way to complete the percent completion. So, how much we have done it, what is the total number of codes, but what if the task is to test the software? So, here we have run a known number of tests, but how many remains to be run. So, known upon how many is remaining. So, that will give you the percent completion. So, estimating percent completion, there are different principles. So, there are different conventions used to aid in estimating percent completion. The first custom is 50-50 rule. Here the 50% completion is assumed when the task is begun and remaining 50% when the work is complete. So, that means 50% is completed, remaining 50% is not yet completed. This seems to be most popular rule, probably because it is relatively fair and does not require effort of attempting to estimate task progress. Since it gives credit for half of the task as soon as it has begun, it is excessively generous at the beginning of the task. Then it does not give credit for other half until the task is finally complete. It is excessively conservative toward the end of task, thereby tending to balance out on an overall basis. The next custom is 0-100% rule. This rule allows no credit for work until the task is complete. With this highly conservative rule, the project always seems to be running late until the very end of the project, when it appears it suddenly catch up. Consequently, the earned value line will always lag the planned value line of the graph. I will explain this concept earned value, planned value, but at present you take it that there will be that the earned value will always lag when you follow the 0-100% rule. I will explain the concept of earned value, planned value after some time. This is an example of earned value analysis graph. You see here there is a actual cost is there, there is a planned value is there, there is a earned value is there. So, when you follow 0-100% rule, so the earned value will always lag behind the planned value. I will explain what this term in coming 2 minutes. The next one is critical input use rule. This rule assigns task progress according to the amount of critical input that has been used. Suppose if the critical input is amount is used more, means the more quantum of work is completed. So, obviously the rule is more accurate if the task uses this input in direct proportion to the true progress being made. For example, when building a house, the task of building the foundation could be measured by the cubic yards of concrete poured. So, if there is a more concrete poured, then we can say the more work has been completed. Another example, the task of framing the house could relate to the amount of lumber used. Another example, the roofing task could relate to the sheet of 4x8 foot plywood used. So, based on the scarce material used, we can measure the progress of that work. The next convention is proportionality rule. This commonly used rule is also based on proportionalities, but uses a time as a critical input, time or cost. This divides actual task time to date by the scheduled time for the task to calculate percent complete. If desirable, this rule can be subdivided according to the sub activities within the task. For example, suppose that progress on a task depends on purchasing large expensive machine to do a long and difficult task. However, just having machine does not contribute to substantial task progress. So, if there are two activities, the proportionality has to be done independently. Now, we will discuss about earned value chart. A graph illustrating the concept of earned value, such as that shown in the figure, can be constructed using aforementioned rules that provides the basis for evaluating cost and scope to date. So, this is the figure which I was given is the earned value chart. I will explain what are the element is there in this chart. If the total value of the work accomplished is in balance with the planned cost as well as it is actual cost, then the top management has no need for detailed analysis of individual task. It implies, you see, this represents the actual cost, this represents the planned value, this represents about the earned value. If all these points are merging, then there is no worry about for top management about measuring, because the project is going as per our plan. But I will explain what is this meaning of earned value. So, the concept of earned value combines cost reporting and aggregate scope reporting into the comprehensive chart. That is application of this chart. Now, we will discuss about various terminologies which are used in this chart. The first one is earned value, EV, that is about this chart. So, earned value is the way to measure how much value or progress a project has achieved compared to the planned or budgeted amount. Now, we will talk about this, what is this PV, planned value. So, planned value in a project management is the amount of work that was expected to be completed at a specific point in time based on the project plan and schedule. For example, you see the time variance on the 10th day, this much amount of work has to be completed, that is the planned value. The next element in this chart is actual cost, this one AC, actual cost. Actual cost in project management refers to the total amount of money spent or incurred on a project up to the specific point in time. So, within the 10th day, this much cost was incurred. So, this much amount of work is planned. Next, we will talk about estimate at completion, this one. So, estimate at completion is a projection of the total cost of the project based on the actual performance to date. So, what says that? So, for the 10th day the actual cost is this much. When you complete the project, so what will be the actual cost, that is called estimate at completion. So, we are projecting, for example, 10th day actual cost incurred is this much. So, at the time of completing this project, what will be the actual cost? So, estimate at completion is calculated actual cost plus BAC is budget at completion. So, this will be the budget at completion, that means when you complete the project, what will be the planned budget. So, actual cost plus budget at completion minus earned value, this earned value, what is the actual work done. Okay. So, that is the estimation at completion. The next term is budget at completion, here this curve. So, budget at completion refers to the total budgeted cost for the entire project. The next term is ETC, this ETC. So, ETC stands for estimate to complete. So, estimate to complete represents estimated cost required to complete the remaining work in the project. It is a projection based on the project's current performance and expenses. You see that? So, currently you are here, this much cost. So, at the time of completion, how much cost is going to be incurred? So, that is called estimate to complete. Estimate to complete. So, this one, so this is nothing but estimate at completion, this one minus this one, actual cost. So, we will get estimate to complete. In simple terms, ETC provides an estimate of how much more money will be needed to finish the remaining project work given the project's current performance and expenditure, that is your ETC, that is estimate to complete. The next terminology is called schedule variance. Schedule variance is a measure that indicates whether a project is ahead or behind the schedule at a specific point in time. So, scheduled variance is you see this is our earned value, this is our planned value. So, when you subtract here earned value minus planned value, so that means we are lagging. So, what will happen? Schedule variance will be negative. So, here SV is the schedule variance, EV is the earned value. I already told you how to get the earned value. The PV is the planned value, that will be given to you. The next terminology is the cost variance, CV. You can see this one. So, cost variance is the measure that indicates whether a project is under or over budget at a specific point in time. So, the formula for cost variance is earned value minus actual cost. Here also it will be negative because the actual work done is less, but the cost is more. When you do AV minus AC, you will get a negative. As per this graph, we are not doing as per the cost that has to be incurred. And what is the implication of this cost variance, schedule variance and time variance? So, cost variance, as I told you, this is earned value minus AC. So, here cost overrun is negative. Suppose if you are getting cost variance is negative, that means you have exceeded the cost to complete the task. Now, scheduled variance, we know that it is EV minus earned value minus planned value. So, SV is negative, it is behind the schedule. So, schedule variance is negative means it is behind is negative. So, time variance. So, time variance is, you see this is scheduled time, this is actual time. So, what is happening here? Scheduled time is less, actual time is more. So, if the time variance is negative, that means there is a delay in the project because ST minus AT will be the negative. Typically, variances are defined in such a way that they will be negative when the project is behind the schedule or over the cost. That is why we start with always EV minus PV for schedule variance. For cost variance, we are writing EV minus AC. As we have noted, however, this practice is not universal either in the literature or in practice, but in this class we are going to follow this way. The variances are also often formulated as ratios rather than difference. So, cost variance become the cost performance index CPI. So, instead of subtracting EV minus AC, we are going to divide by AC, that will become cost performance index. Schedule variance become your earned value minus planned value, so that will become scheduled performance index. So, the time variance become time performance index. So, scheduled time upon actual time. So, instead of subtracting, we are dividing by that. So, wherever this ratio is less than 1, that is not desirable. Use of ratios is particularly helpful when an organization wishes to compare the performance of several projects or the project managers or the same project over different time period, because it is in terms of percentage it is easy to compare. As we just noted, however, the accuracy and usefulness of all these performance measures depends on the degree in which estimates of percent completion reflect reality. So, we talked about different customs for measuring percent completion. So, how accurate that percent completion, based on that only your cost variance, schedule variance or other indicators will be so accurate. Now, we will take an example for doing this earned value analysis. Assume that operations on a work package were expected to cost $1,500. So, the planned value is $1,500 to complete the package. They were initially scheduled to have been finished today, but at this point, however, we have expended $1,350, that is the actual cost, and estimate that we have completed 2/3 of the work. So, the percent completion is 2/3 of the work. So, what are the cost and scheduled variance? So, first what we do? First we will find out the cost variance. So, the cost variance is earned value minus actual cost. So, in our problem you see that the earned value is at the bottom, the middle is the actual cost, the top one is plant value, because the plant value is 1500. So, the actual cost is 1350, but when you find the earned value, what will happen? It will be 1000, because 2/3 of 1500 will be 1000 minus 1350, it will be minus 350. So, the cost variance is negative, that means we are spending more money. Then schedule variance. So, schedule variance is EV minus PV. EV is 1500 multiplied by 2/3, you will get 1000 minus 1500, again it is minus $500, that is scheduled variance. So, cost performance index EV upon AC, EV we know 1500 multiplied by 2/3 upon actual cost is 1350, we are getting 0.74, and scheduled performance index. So, EV upon PV we are getting 0.67. Two ratios are less than 1, it is not desirable. In other words, we are spending at a higher level than our budget plan indicates, and we are not as far long as we should be, because we are lagging. We can also use scheduled performance index to calculate the time variance if we realize that scheduled time should conceptually be in proportion of EV upon PV. So, what is the scheduled time? So, scheduled time we can write, so actual time multiplied by scheduled performance index. So, instead of this we know time variance is equal to ST minus AT. So, instead of my scheduled time you can substitute this. So, you will get AT EV upon PV minus 1, this is a whole bracket here, whole bracket. So, when you simplify that, so this will be AT, then scheduled performance index minus 1. Now, there are different possibilities, this arrangement of your actual cost, earned value and baseline planned value, and resulting in 4 combination of positive and negative schedule variance and cost variance. The first situation, so the actual cost is less, earned value is more. See, we can find out scheduled variance. Scheduled variance is EV minus PV, it will be positive because EV is above top. So, cost variance is EV minus actual cost. So, both are positive. The second situation, actual cost is more than the baseline planned value, but the EV also more. So, in this situation also, suppose if we are finding scheduled variance, so EV minus PV will be positive, then cost variance EV minus AC also will be positive. This is the two possibility. Other two possibility, you see the baseline is here, actual cost is more, but the EV is less. So, here scheduled variance will be EV minus PV, it will be negative, cost variance will be EV minus actual cost, here also it will be negative. The next situation, this is what I have shown previously, here the scheduled variance, schedule variance. So, EV minus PV obviously it will be negative, then cost variance EV minus AC, this also will be negative. This is the one situation. Other situation, see the baseline PV is there, EV is more, AC is less. So, what is the SV schedule variance? We know EV minus PV. So, that will be negative, EV is below the PV, but what is the cost variance? EV minus AC. So, this will be positive. The other situation, that baseline is at the bottom, EV just above that, but AC is on the top of that. So, here SV schedule variance is EV minus PV, this will be positive, then cost variance is EV minus AC. So, this will be negative. So, there are 6 possibilities where we can get different combination of schedule variance and cost variance. Now, we will from there what we have continued in that example, we can find out the cost schedule index. What is that cost schedule index? When you multiply cost performance index and schedule performance index, we know the formula EV by AC upon EV by PV. When you simplify that, you will get EV square upon AC and PV. EV square we know how to find out, 1500, then percent complete 2 upon 3 whole square upon actual cost is 1350, planned value is 1500. So, we are getting 0.49. So, cost schedule index, if it is less than 1, indication of the problem. From there we can find out estimated cost to complete, ETC. So, we know we have studied estimated cost to complete is baseline cost, that is 1500 minus EV, earned value 1000, upon CPI, cost performance index. So, we are getting ET. This is additional cost which is required to complete the whole project. So, from there estimated actual cost to complete we can find out. So, already we got ETC, we know what is actual cost. So, this will be the total budget required to complete the task. Initially we planned it is only $1500, but because of this delay, so instead of 1500 now the cost will be 2026. Now, I have taken another example to construct the earned value chart. So, now what we are going to do, we are going to update a project's earned value. I have taken one sample problem, from there I will explain. So, we use a simple example to illustrate the process of determining the baseline budget and interim earned value and actual cost for a project. So, the table on the right hand side presents the basic project information and updated information as of day 7 in the project. So, there are activity A, B, C, D is there, predecessor is there, day's duration is there, this is budgeted, but this is actual expenditure. For example, you say activity A, the planned is $600, but the actual is $680, it is increased. But activity B, the planned budget is 3000, but we have decreased the budget requirement by $30, so it become 270. By using this table, I am going to construct the earned value analysis chart. So, for the given problem, the planned activity on node diagram is shown, here it is shown, where the path ACE is the critical path. So, this one start ACE. See the legend, the ES on the left side of this rectangle says earliest start, earliest finish, latest start, latest finish. So, after the letter English alphabet we written the duration. For example, critical path, what is duration? 3 plus 5, 8 plus 2, 10 days. What was actually happened in the project is that the first activity A, this A took 4 days instead of the planned 3 days to complete, delaying start of both activities B and C. So, activities B and D are proceeding as expected, except of course for their 1 day delay in initiation. But anyway, path ABD was not critical path for the project. So, activities A and B are both completed, this completed, and their actual cost also shown here. The cost to date for activities C and D are not known to us. However, due to its delay, activity A cost $80 more than the budgeted, it becomes 680. Hence, the project manager is trying to cut the cost of remaining activities, and we see that activity B become $30 under budget, which helps but does not fully offset the previous overrun. So, now this is the baseline budget using 50-50 rule. We are going to use 50-50 rule. So, activity A, so activity A has 3 days duration. So, as soon as it started, so we are dividing, this is 300, allocating $300, here it is $300. So, first 50% of the work we are allocating $300, the next 50% of the work allocating another $300, but the duration is 3 days. For example, B, the duration is 2 days. So, we are allocating 150, 150 because we follow 50-50 rules. Then C, duration is 5 days. So, here also initial $400, remaining $400. Similarly, for D, it is start on the 6th day, 1, 2, 3, 4, 5, 6th day, here beginning $200 and the end $200. Similarly, for activity E, the beginning $200, end $200. We know it is going to take totally 10 days. Now, we are going to find out the total cost for each day. So, day 1 300, day 3 300, day 4 550, day 5 150, day 6 200, day 8 400, day 9 400, day 10 200. Then we are finding this cumulative cost 300 plus 0 300, 300 plus 300 600, 600 plus 550 1150. Like this we got cumulative baseline cost. So, this the thick line in this figure says about baseline actual cost, but our concern is we are going to consider 7th day. So, this is the baseline budget. So, on the 7th day we are going to measure our earned value and actual cost. So, on the 7th day, so what has happened, the activity A is delayed by 1 day. So, what is happening, instead of the 3rd, now it is pushed to 4th day. So, the earned value also 300. So, the cumulative earned value is 300, but on the 4th day, see, because we pushed 1 day late, on that means 1 day ahead on the right hand side. So, now instead of 3rd day, so activity A will be finished on the 4th day, but the additional cost is instead of finishing on 3rd day, it is pushed on the 4th day. So, the cost is allocated on the 4th day. So, what is happening? The additional cost is $80 more, instead of 600, now it become $680. Now, for activity B, see, activity B should be in the 4th day, now it has gone to on the 5th day because of delay of activity A. Activity C also pushed on the 5th day. So, 400 plus 550, then the cumulative value 600 plus 550 is 1150. Then activity B 150, the earned value is 150 only, but activity D it is 200, the earned value is only 200. Now, after finding the earned value, we have to find the cumulative value, but what has happened here? Here $80 is increased, but the actual cost for activity B is 270 instead of, because there is a $300 less. So, 270. So, when you find cumulative actual cost, so 680 plus 270, it is 950. So, we got again 950. So, what has happened? So, this thin dotted line is the cumulative earned value, then the thick dotted line is the actual cost. So, what I have explained here, I have explained with the help of an example. If there is a delay in activity, that much delay will be pushed on the right hand side on this table, and due to that delay, what is the additional cost, that also has to be added to the your actual cost column. So, then we can find out the actual cost curve, earned value and baseline actual cost. By using this graph, we can find out further analysis, cost variance, schedule variance, cost performance index, schedule performance index, etc. and so on. So, in this lecture, I discussed about earned value analysis, then earned value chart and calculation also I have explained. Then I have explained different customs for measuring the work completed, that is called percent completion. Then I have explained various terminologies, various variances. Then with the help of an example, I have explained how to construct the earned value chart. Thank you.